This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello, this is Jeremy Jung for Software Engineering Radio. Today, I have John Doran with me. John is the Director of Engineering at Forrest, a Dublin-based SaaS company that processes appointments for the hair and beauty industry. He previously worked as a technical lead at Travelport Digital, where he supported major airlines and hotel chains with their mobile platforms. I'll be speaking with John about the early days of their business, the challenges they faced while scaling, and how they were able to reshape their processes and team to overcome those challenges. John, welcome to Software Engineering Radio.
Hey, Jeremy. Thanks so much for having me.
The first thing I'd like to discuss is the early days of Forrest. To just give the listeners a little bit of background, what type of product is Forrest?
Sure. So Forrest is essentially, it's a salon software focused in the hair and beauty industry. And it didn't actually start off as that. Back in 2003, it was actually a messaging service, actually built by a few students in Trinity College, one of which his name was Ronan Percival. Ronan is actually our current CEO. So that in 2003, that messaging service was supporting nightclubs, dentists, various small businesses around Dublin. And the guys were finding it really hard to get some traction in those various different industries. So Ronan actually went and worked as a hair receptionist in a salon. And what he learned from that was that through using messaging and a platform, that they were able to actually increase revenue for salons and actually get more money in the tills, which was a hugely powerful thing. So from there, they were able to really focus on that particular industry. They built supplementary features and a product around that messaging service. So in 2004, it became a kind of a fully fledged appointment book. And from there, then they integrated that appointment book with the messaging service. So by 2006, then I guess you could classify Forrest as a full salon software. So it had things like stock take, financial reporting, and staff rostering. That fully based salon software system was pretty popular in Ireland, and actually between 2006 and 2008, they became the number one in the industry in Ireland. So what that meant was, the majority of salons in Ireland were running on the Forrest platform, and that was actually an on-premise system. So all the data would have been stored locally in the hair salon, and there was no back end.
Just so I understand correctly, so you say it was running on-premise.
Mm-hmm.
It was an appointment system. So is this where somebody would come into the salon and make an appointment and they would enter it into a local computer and it would be just stored there?
Exactly. So what Ronan figured out throughout his time working in the salon, that by actually sending customers text messages to remind them about their appointments really helped cut down the no-show rates, meaning that customers did turn up for their appointments when they were due, and meaning that the staff members didn't have to sit around waiting for customers to walk in. So as Forrest, I guess, as a company developed, we moved into building extra features around that core system, which is an appointment book, which manages the day-to-day roles of a hairstylist. So we built email and marketing retention tools around that. I guess a really important point about Forrest's history is when the recession hit in 2008 in Ireland, we moved into the UK. So as we were kind of the number one provider in Ireland, we felt when the recession hit that we needed to move into the UK. But being on-premise meant there was a lot of friction actually installing the system into the salons. So in 2011, they actually took a small seed round to build out, I guess, the cloud backend. Once that kind of cloud backend was built, it took about a year to get it off the ground and released. And as the company kind of gained traction in the UK, they migrated all of their on-premise customers onto the cloud solution.
I guess you would say that when it was on-premise, a lot of the engineering effort or the support effort was probably in keeping the software working for your customers and just addressing technical issues or questions and things like that. And that was probably taking a lot of your time. Is that correct?
Precisely. The team was quite small. So we had 5 engineers who were essentially building out the cloud backend and 1 engineer who was maintaining that Delphi on-premise application. So what was happening was our CEO, Ronan, was actually the product owner at that time. And the guys were making pretty drastic and kind of quick fire decisions in terms of features being added to the product based on, getting a certain customer in that really needed to pay the bills. And some of those decisions, I guess, made the product a bit more complex as it grew. But it certainly was a big improvement from the on-premise solution.
So the on-premise solution you said was written in Delphi. Is that correct?
Yeah.
When it was first started, was it just a single developer?
Exactly, yeah. So it was literally put together by some outsourcers and a single developer managing it. There was no real in-house developers. It was a good bit of turnover there. But when that small seed round came in, the guys put together the foundations of the cloud-based backend, which was a Java kind of classic end-tier application with WebSocket to update the appointment screen if anything changed on the backend. And you would kind of consider it a majestic monolith as such.
When you started the cloud solution, were you maintaining both systems simultaneously?
Yeah, so for a full year, the guys were building out that backend, and at the same time, there was one guy who was literally fixing bugs on that Delphi application. And just to kind of give you an example, one of the guys who was actually working on support, he actually went and taught himself SQL, and he used to tunnel into the salons at nighttime to fix any database issues. And
oh wow,
yeah, so it was hardcore stuff.
Mm-hmm.
Another big thing about not being cloud based, and one of the big reasons we needed to become cloud based was we as people move online, and it's quite common to book your cinema or something else online, but Ronan could see that trend coming for online bookings, and we needed to be cloud-based to build out that online booking system. And just to kind of give you an idea of the scale, like last year, we would have processed about over €2 billion worth of transactions through the system. So it's really growing, and it's huge scale at the moment. But I guess looking back at the past, the guys would have built a great robust system getting us to about that 1,000 salon mark, particularly in the UK. But that would have been the point that the guys would have started seeing some, shakiness in terms of stability and the speed at which we could deliver new features.
You were saying the initial cloud version took about a year to create?
Exactly, yeah.
And you had 5 engineers working on it after the seed round?
Mm-hmm.
At that time, when you first started working on the cloud version of the application, did you have a limited rollout to kind of weed out defects, or how did you start transferring customers over?
So there was definitely some reluctant customers to move across. We did it, I guess, gradually. There was a lot of reluctance for people. People were quite scared of their data not being stored in their salon. So it was quite hard to get some of those customers across. And only 2 weeks ago, we actually officially stopped supporting that, and our final 2 customers have finished up. So, it took us a good 7 years to finish that transition.
Okay, so it was a very gradual transition where did you ask customers whether they wanted to move, or how did you?
Oh yeah, it was a huge sales and team effort to get people across the line. But I would say the majority of people either would have churned or would have moved across. The more forward-thinking people, they would have been getting new features and a better service.
Right. So it's kind of more of a marketing push from your side to say, hey, if you move over to our cloud solution, you'll get all these additional capabilities, but it was ultimately up to them to decide whether they wanted to move.
Yeah. So, some companies, they kind of build a product with a different name and they try and sell it. But Forrest, we actually kept the UI very similar. So it wasn't very intrusive to the users. It was just kind of seen as an upgrade with, I guess, less friction.
Right. I want to talk a little bit about the early days where you said you spent about a year to build the MVP.
Mm-hmm.
At that point, let's say after that year had passed, were you still able to iterate quickly in terms of features, or were you having any problems with performance or downtime at that point?
So in 2012, when the cloud-based product launched, particularly in the UK, once we hit about 1,000 customers, we started to see creaking issues in the back end, lots of JVM garbage collection problems, lots of database contention, and lots of outages. So we got to a point where we were throwing hardware at the problem to make things a little bit faster. Some other problems were we kind of relied a lot on a single person to do a lot of the deployments. So it wasn't really a team effort to ship things. It was more so developer finishes code in the machine, push it off. Maybe at the end of the month we'd ship. I guess the big problem was the stability. So essentially what happened was, in terms of the architecture, we were introducing caches at various levels to try and cope with performance. So a layer of caching on the client side was introduced. Memcache D was introduced. Level 2 Hibernate caching. Always just, really focusing on fixing the immediate problem without looking at kind of the bigger picture. Once I mentioned that 1,000 salons as a marker. I guess once we hit like 1,200, the guys had to introduce the idea of silos, which was like essentially 1,000 customers are going to be linked to a specific URL, and that URL will host the API, return back the data that they need, and then the other silo would service the other, 200 growing to say 1,000 businesses. So essentially, if you think about it, you've got, I guess, a big point of failure if that server goes down. There's no load balancing between servers, and those two servers are their biggest size possible. So I guess a big red herring was the cost, I guess, implications of that. It was the largest instance type on Amazon at an RDS and EC2 level.
The entire system was on a single instance for each silo?
Yeah, so if you imagine when you log in, you'll get returned a URL for a particular silo. So what would happen then would be X businesses go to that silo and Y businesses go to the other silo. And what that did was basically it load balanced the businesses at a kind of a database level.
You were mentioning how you had like different caching layers, for example, Memcache D and things like that.
Yeah. Mm-hmm.
But those were all being run on the same instance. Is that correct?
They would have been hosted by Amazon.
Okay, so those would have been Amazon's hosted services. So
yeah.
Okay.
It's kind of like when you build that MVP or you build that initial stage of your product, kind of you're focusing on building features, you're focusing on getting bums on seats, and it was that point, that 1,200 to 1,000 salons where we felt that pain, that scaling pain.
Mm-hmm. So in a way, like you said, you were doing multi-tenancy, but it was kind of split per 1,000 customers.
Yeah, exactly. So if you imagine if a failure happened on one of those servers, there is no fault tolerance. If the deployment goes wrong in terms of like putting an instance in service, those 1,000 customers can't make purchases. Their customers can't make online bookings. There's no appointments being served. You can't run transactions through the till. So it would cause huge friction.
Right. What were the managed services you were using in combination with the EC2 instance?
So a really good decision at the start of the guys moving to cloud was making a big bet on Amazon in terms of utilizing them for RDS, EC2, caching. There was no deployment stack, or there was no deployment infrastructure as code. It was all, I guess, manually done through Amazon console, which is something we later address, which we'll chat about. But it was all heavily reliant on Amazon.
Mm-hmm. And you had mentioned that you were relying on one person to do deployment. Was that still the case at this time?
Yeah. So up until, I guess, 2014, it was all reliant on one guy who literally had to bring his laptop on holidays with him and tether from cafes if something went down. To deploy new code, he was the only guy who really knew how to do it. So it was a huge pain point in bus factor.
Mm-hmm. So it sounds like in terms of how the team was split up, there was basically you have people working on development and you have a single person in the sort of ops role.
Yeah, and essentially when this kind of thing happens, the people who write the code don't ship it. You get all sorts of problems. in terms of dependencies and tangles and just knowledge, knowledge silos. And also, because the guys were working kind of in their own verticals in different areas of the product, there was no consistency in terms of the engineering values, how they were working, practices, procedures, deployments, that sort of stuff. It was all very isolated. So people did their own thing. So you could imagine, for say, trying to hire someone new would be quite hard, because it would, for someone to come in, very, very different depending on which engineer you talk to. That makes sense.
Yeah. Was this a locally located team, or was this a remote team?
Yeah. So most of the guys were actually in Dublin. One or two people traveled a little bit, worked remotely, and a couple of people did actually move abroad. So it was predominantly based in Dublin, but some people traveled a bit.
In terms of processes for someone knowing how to deploy or how to work on a feature, it was mostly tribal knowledge. It's more just trying to piece together a story from talking to different people. Is that correct?
Precisely. So you had no consistency in languages or frameworks, except I would say that monolith, that initial part of the platform, was extremely consistent in terms of the patterns used, the I guess the way it communicated with the database, and how the API was built was extremely strong, and is the heart of the organization. So, say for example, there's a lot of really good say integration and unit tests there, but they got abandoned for a little while, and we had to bring them back to life to enable us to start moving faster again, and to give us a lot more confidence in our releases.
So it sounds like maybe the initial version in the first year or so had a pretty solid foundation, but then as I'm not sure if it was the team that grew or just the rate of features. Would you say that kind of?
I would say it was a combination of the growth of the company in terms of the number of customers on it, and the focus on delivering features and focusing on feature development, rather than thinking about scalability and being extremely aware of it.
How fast were you gaining customers at that time? Was this a steady increase or large spikes?
Oh, you're talking 30% annually. So
30% annually. Okay.
Yeah. And really, really low churn rate as well.
So what would you feel was the turning point where it felt like your software had, or your business had to fundamentally change due to the number of customers you had?
So it was essentially those issues around stability and cost were unsustainable for the business. Customers complaining, our staff not being able to do their job. So, part of Forrest's core values and mission is to help the salon owner grow their business and use the tools that we provide to do that. And if people are firefighting and not being able to support our customers, to being able to help them send really great marketing campaigns to boost their revenue, if we're not doing that, we're firefighting, the company would have been pointless. So we weren't fulfilling our mission by coping with outages and panicking all the time. The costs, again, were unsustainable. And, the team, was just, I guess, uncomfortable with the state we were in. So the turning point would have been, I would say, in like 2014, when we essentially hired in some people who had more experience in, I would say, high scalability systems, and people who cared a little bit more about quality and best practices. So when you hire 3-4 people like that, you bring in a different way of thinking. You hire these different values. When you try to talk to a team and try and get these things out, they're normally quite organic. But if you bring people in from maybe a similar from a different industry but similar experience, you kind of get that for free. And that's what Forrest did. So basically in 2014, and since now, we've invested heavily in hiring the right people in terms of how they operate and in terms of how they think, but also bringing that back to our values and what we try to do.
Do you think that bringing in, new people, new talent is really one of the largest factors that allowed you to make such large changes, to change your culture and change your way of thinking?
The other thing would be, I would say, the trust that Ronan, CEO, and the leadership team Forrest has, and their openness to change. I think that a lot of other organizations would be quite scared of this type of change in terms of heavily investing in the product to make it better. Just like from experience and talking to other people, it would have been very easy to not invest, and just leave the software ticking along with bugs and handling the downtime. But it was about the organization and their values around really helping the salon owners and not spending that time firefighting.
So it sounds like within 2 years or so of launch was when you decided to make this change.
Yeah, so it's not an easy one to make because it's really hard to find talent, and we were lucky to really get some great people in, and it wasn't about making radical change at the start. It started from foundations, so it was things like let's get a continuous integration server going here, guys, and let's bring back all the broken tests and make sure they're running so that we can have a bit more confidence in what we ship. We introduce code reviews and pull requests back into things, and a bit more collaboration and getting rid of those pockets of knowledge, reliance on individuals.
I do want to go more into those a little bit later.
Okay.
But before that, when you were having performance issues or having outages before all these changes, how were you finding out? Was it being reported by users, or did you have any kind of process, to notify you?
So the quite common thing was basically the phones would light up. There was very, very little transparency of what was going on in the system. It got to a stage where we actually installed a physical red button on the support floor, which texted everyone in the engineering team.
Oh, wow. Okay.
Yeah.
One of the things that we often hear is when a system has issues like this, it's difficult to free up people to fix the underlying problems due to the time investment required. And as you mentioned, all the firefighting going on. How did you overcome this issue?
So I guess, beforehand it was a matter of, restart the server, let's keep going with our features. But it was really about stopping to think about, what really happened here. And, maybe let's write down an incident report and gather some data about what actually happened under the hood. And a few things, a few key questions could be raised from that, like, what are we going to do to stop this from happening again? Why didn't we know about it before the customers? And, what were the steps we made to reproduce and actually fix this issue? And what are the actions that are going to happen? And how are we going to track that those actions do happen after the issue?
Let me see if I understand this correctly. You actually did build sort of a process when you would have incidents to figure out, okay.
That was the first step, I would say. Yeah, so let's figure out what happened and how. And it was just about gathering data and getting information about what was really going on. So It allowed us to identify, common things that happened that maybe usually we would just, restart server and forget, or fail over database and everything's normal in a couple of hours. But as we started gathering that data, we started to see common problems. So maybe, our deployment process isn't good enough and it's error prone, or this specific message broker isn't fault tolerant, or the IOPS in the database are too high at this time due to these queries happening. But after we got that data, and we started really digging deep into the system, we realized that this isn't something that you could just take 2 days in your sprint to start to fix. And just coming back to your question on finding that time to fix things, we kind of had to make a tough call when we looked at everything to say, let's stop feature work and let's stop product work and let's fix this properly.
Okay, yeah. So basically you got more information on why you were having these problems, why you were having downtime or performance issues, and started to build kind of a picture of and realize that, oh, this is actually a very large problem. And then as a company, you made the decision that, okay, we're going to stop feature development to make sure we have enough resources to really tackle this problem.
Precisely. And from the product side of things, this was a big driving factor in it. We wanted to build all these amazing features to help salons to grow, but we just couldn't actually deliver on them, and we couldn't have any predictability on when we delivered them because of that firefighting, and because we were sidetracked so much. There was no confidence in the release cycle and stability or what we could actually deliver. So it was a pretty hard decision for us to make in terms of the business, because we had a lot of deliverables and commitments to customers and to to our sales team. So we had to make that call.
You were mentioning earlier about how you started to bring in a continuous integration process.
Mm-hmm.
Before you had done that, you also mentioned that there were tests in the system initially, but then the tests kind of went away. Could you kind of elaborate on what you meant by that?
Yeah, so as I said, like the kind of the core of the system was built with a lot of integrity and a lot of really good patterns. For example, a lot of integration tests running against the APIs were written, and maybe were written against a specific feature, but they were never ran as a full suite. So what would happen was there'd be maybe one or two flaky ones, and they because there was no continuous integration server, it was easy enough for a developer to run specific tests for that functionality that they were building. But because there was the CI wasn't there was no full suite ran. So when it came time to actually do that, we realized 70% of them are broken.
So they were building tests as they developed, but then they were maybe not running those as the software
before commit or merge.
Right. Okay.
Yeah.
And so adding the continuous integration process, having some kind of build process, really forced people to pay attention to whether those tests were working or not.
Mm-hmm. Exactly. And just a step on from that was, a huge delay in getting stuff to test because we relied on that one guy to build stuff. And actually that was, done from a little Linux box in the engineering floor, which was quite temperamental. You'd be quite delayed in actually even just getting stuff into people's hands. And it's kind of what the core of software development is all about, right? It's, getting what you build into people's hands, and we just couldn't do it.
Just because the process of actually doing a build and a deployment was so difficult.
Yeah, exactly.
When you added the continuous integration process, were there other benefits that you maybe didn't expect when you started bringing this in?
So I mentioned the deployments as a big one. I think the people started to see real benefit in terms of their workflow. I guess along with the continuous integration, there was more discipline in terms of how we worked. So the CI server introduced a better workflow for us, and it helped us see real clarity in terms of the quality of the system, where it had coverage, where it didn't, and it also helped us break up the system a little bit. So I mentioned Majestic Monolith. So it was actually, when we went to look at it, there was 5 application servers sitting in one repo, and the CI server and some crafty engineering helped us split that up quite well to break out that repo into multiple application servers.
So actually bringing in the continuous integration actually encouraged you to re-architect your application in certain ways and break it down into smaller pieces?
Exactly, yeah, and really, it was all about confidence and being able to test and know that we weren't regressing.
What do you think people saw in terms of the pain or the challenges from that sort of monolith setup that you think sort of inspired them to break it up?
The big one was a bug fix in one small area of the system meant the whole stack had to be redeployed, which took hours and hours. The other thing would have been the speed of development in terms of navigating around a pretty large code base, and the slowness of the test suite to run, which was around 35 minutes when we started and got them all green.
The pain of running the tests and having it possible to break so many things with just one change maybe encourage people to shrink things down so they wouldn't have to think so much about the whole picture all the time.
Exactly. We started to see, a small fix or a small feature breaking something completely non-related. Typical example would have been due to HTTP connection configuration on a client, breaking completely unrelated areas of the system.
Okay. One thing I'd like to talk about next is the monitoring. You mentioned earlier that it was really just phone calls would come into support, and you even had the big red button you could press. What did you do to add monitoring to your application?
It's pretty important to mention that, we talked about making a decision to stop, to down tools and start fixing stuff. So that's when we started, looking at the monitoring and everything else, like continuous integration, bring back tests. But a kind of a key point of this evolutionary project was the monitoring. So we did a few things. So we upgraded our systems to be using New Relic to help us find errors, and it was there, but it wasn't being utilized in a good enough way. So we used a PM there. We looked at CloudWatch, and we introduced CloudWatch metrics to help us watch traffic, to help us see slow transactions. Log entries helped us a lot in terms of spotting anomalies in the logs. Pingdom was actually a really surprising good addition to the monitoring. It simply just calls any health check endpoint you want and has some nice Slack and messaging integration. That was great for us. It's helped us a lot. So we did a couple of other things, like some small end-to-end tests that would give us a kind of a heartbeat to how the system was running. And they were also gave us the kind of confidence that we would know about an issue before a customer, and being able to allow us to get rid of that red button.
All of these are managed services that you either send logs to or check health endpoints on your system.
Mm-hmm.
Did you configure them somehow to text your team or send messages to your team when certain conditions were met? Or
so we started with just like a simple Slack channel that would send us any kind of DevOps related issues into there, and that's kind of what helped us change the culture a little bit in terms of being more aware of the infrastructure and the operations. And Pingdom was great for setting up a team with people who would get notifications for various parts of the system. And our CloudWatch alarms, we set up a little Lambda function that would just forward on any critical messages to text us.
And before this, you said it was basically just user calls, and now you are actually shifting to kind of proactively identifying the problems.
Yeah, exactly. There was some really small alerts there, but nothing as comprehensive as this. We actually we changed some of the applications. We introduced health endpoints to all of them, so they would report on their ability to connect to a message broker, their ability to connect to a database, any dependencies that they actually needed. We would actually check as part of pinging that endpoint. So if you hit any of our servers, any new or older ones, they would all have like a /health endpoint, and that would give you back a JSON structure and give us a good insight into how healthy that component was.
And if there was a problem and you were trying to debug issues, were you mostly able to log into these third-party services like Log Entries or New Relic to actually track down the problem?
Yeah, so again, those services give us that information, but it would always come back to, being if you needed to get into a server. And a big thing, which we'll talk about, is Docker. We don't have SSH access into those servers, so we rely on those third parties to give us that information. But in the past, maybe we would have had to get in and look at the processes and take dumps. But with log entries and New Relic, we were able to do that stuff without needing to.
So previously, you might have someone actually SSH into the individual boxes and look at log files and things like that.
Exactly. So quite easy when you've got one server, but as we'll discuss, when you've got many small containers, and it's extremely complicated.
Mm-hmm. Next, I'd like to talk about, since you mentioned Docker, how did you make the decision to move to Docker?
So it was something our CTO was really aware of, and he really wanted us to explore this. The big benefits for us was that shift in mindset of one guy not being responsible for deployments, but us actually developing and using Docker in our day-to-day workflow, and the cost implications as well. That the fact that we could, instead of having that, say, 8x large, we could have running one application server, we could have 12 containers running on much smaller containers running on EC2 instances. So it was that idea of being able to maximize CPU and memory was a huge benefit for us that we saw.
So the primary driver was almost your AWS bill or your...
Big time, yeah.
Okay.
Portable applications that had much less maintenance. We didn't have to go in and worry about it, because we had we mentioned this earlier, like these kind of siloed tech stacks. We didn't need to worry about a Ruby environment or a PHP environment or Java JVM install. It was just in the container, and it was a hugely big and important thing for us to do. And it was really kind of well thought out by our CTO at the time.
So you mentioned like Ruby containers and JVMs and things like that. Mm-hmm. Does your application actually have a bunch of different frameworks and a bunch of different languages?
Yeah. So as we split out that monolith, we also, I guess, started building smaller domain-specific, not micro, I'd say, kind of services responsible for areas of the system. Our online booking stack. So if you go to any of our customers, you can book in their point of sale system in the salon, but you can also book on your phone, and we have a custom domain for every one of those salons. So it's like forrest.com/book/foundation hair. If you click on that, you're going to be brought to the online booking stack, which is a Rails app actually, and an Ember.js front end. So the system, as we started splitting it apart, became more and more distributed, and Docker was great for us in terms of consistency and that portability, particularly around different tech stacks.
Migrating to Docker made it easier for you to both develop and to deploy using a bunch of different tech stacks.
Exactly.
When running through your CI pipeline, would you configure it to create an image that you would put into a private registry, such as Amazon's Elastic Container Registry?
Yeah, so we made the mistake of building and hosting our own registry at the start. We quickly realized the pain in that around 3-4 months in, where and actually at the same time as Amazon released the ECR. So I guess the main reason we did that ourselves was because we were early adopters, and we paid a little tax on that, but we moved to ECR. So our typical application kind of pipeline is build, unit test, maybe integration, acceptance tests, build a container. In some of those applications, they run acceptance tests against the container running on the CI server, push to the registry. And after it's pushed to the registry, then we would configure deployment and trigger it off.
Do you have a manual process where somebody watches the pipeline go through and you make the call to push or not, or is it a automated process?
No, it's automated. So we built a small kind of deployment framework, again, because we were early adopters of Amazon's ECS, their container service. So we built a small deployment stack, which allowed us to essentially configure new services in ECS and deploy new versions of our application through the CI to our ECS clusters. So it was all automated.
Were you using an infrastructure as code solution such as CloudFormation?
Yeah, so when we were looking back at the problems in the good old days, we seen that one was, things were just configured on the AWS console. And we knew we needed infrastructure as code, and we needed repeatability and the ability to recreate stuff. So we used CloudFormation, and essentially something very similar to Terraform. And we do use Terraform for some of our managing our messaging clusters and some other things.
Okay, so you maybe initially moved from having someone manually going in and creating virtual machines to more of a infrastructure as code approach.
Exactly. Yeah.
You had mentioned that one of the primary drivers of using Docker was performance. Did you start creating performance metrics so that you knew how much progress you were making in that front?
Yeah, so essentially the effort to kind of make our infrastructure more reliable, it was a set of steps to get there. And we started with API level testing to make sure that anything we changed under the hood, it didn't break the end-to-end functionality. And we also wrote a bunch of performance tests, particularly around pulling down appointments, creating appointments, and sending large volumes of messages. We knew we couldn't have any regressions there. So we used Gatling to do those performance tests, and we would run that from continuous integration server, and we do various types of soak testing to make sure we weren't taking any steps backwards.
So each time you would do a deployment, you would run performance tests to ensure that you weren't getting slower or you weren't having any problems from the new deployment.
Yeah, I would say though that this kind of effort, and we called it Project Darwin internally, this effort to kind of, it had a few goals, but it was all about, becoming fault tolerant, being more scalable, reducing Amazon costs. And during Project Darwin, we didn't just move our 1,500 salons. We didn't just drop them and move them to Docker. There was so many changes under the hood that these performance tests were key to giving us a pulse on how we were doing. But I guess when we were done with Project Darwin and everything was on Docker and everyone was much happier, we run those performance tests ad hoc and as part of some release pipelines.
Okay, so initially you were undergoing a lot of big changes, and that was where it was really important to check the performance metrics with every build.
Exactly, yeah.
What were some of the big challenges? Because you mentioned you were changing a lot of things. What were some of the big challenges moving your existing architecture to Docker and to ECS?
There was a couple. The biggest, there's two huge ones. So one was state. Getting state out of those big servers was extremely hard. We needed to remove the level 2 cache because we needed to turn that one server into smaller, low balance containers. We needed to remove the state because we didn't want somebody in one computer terminal fetching their appointments and then on their Forrest Go mobile app looking at different data. So we had to get rid of state. And the challenge there was that MySQL performance just wasn't good enough for us. So we actually had to look really hard at migrating to Amazon Aurora, which is what we did. Again, coming back to cost, Aurora is much more cost effective in terms of the system beforehand was provisioned for peak load. So we would have provisioned IOPS for Friday afternoon, the busiest time that the salon was using the system. And we were paying that for the same amount on a Sunday night compared to Aurora, where you're paying for IOPS and the additional benefits of performance around how Amazon rebuilt the storage engine there. So that's the caching side of things. The other big challenge was the VPC. So we needed to get all of our applications into a VPC to be able to use the latest instance types on Amazon. And also for our application to be able to talk securely to an Aurora database. So those two are definitely the biggest challenges.
With the MySQL setup, it sounded like you had to pay for your peak usage, whereas with Aurora, it automatically scales up and down. Is that correct?
No, you're actually charged per read and write. So that would be the big difference.
Oh, I see. Per read and write. Okay.
Yeah.
So it's just per operation. So you don't actually think about what your needs are going to be. It kind of just charges you based on how it's used.
Yeah. The other really nice thing was looking back at our incident reports, a really common issue would have been, hey, the database has ran out of storage. And Aurora does actually autoscale its storage engine.
You mentioned removing state from your servers, and you mentioned removing the level 2 cache. Can you kind of explain sort of at a high level what that means to those who don't understand that part?
Sure. So in the Java world, when you have an ORM framework like Hibernate, essentially when you query the database, that cache will store that data in its level 2 cache. And what that means is that it doesn't need to hit the database for every query. And that was the solution for Forrest as we were in that MVP / early days, but it wasn't the solution for us to become fault tolerant.
So it would be someone makes a query to an ORM. In this case, it's Hibernate.
Mm-hmm.
And on the server's memory, it would retrieve the results from there instead of from the database.
Yeah, exactly.
Okay.
And that's what I was coming back to around querying an API for a list of appointments. If you had two servers deployed with them using an L2 cache, you would get different state because of the cache.
So did you put a different cache in place, or did you remove the cache entirely?
So we removed that cache entirely, but we did have a REST cache, which was Memcache D, and that's distributed, and we used cache keys based on entity versions. So that was distributed and worked well with multiple containers behind a load balancer.
So you remove the cache from the individual servers, but you do have a managed memcached instance that you use.
Yeah, exactly. And getting rid of that level 2 cache, our performance tests told us that MySQL just wasn't performant enough, whereas Aurora was much better at handling those types of queries. Some large joins, it's a big relational database.
So we've talked about adding in continuous integration, monitoring, performance metrics, Aurora, Docker. Did any of these processes require large changes to your code base?
To be honest, not really. It was more about plumbing things together and a lot of orchestration from a human point of view. So people being aware of how all this stuff worked and essentially making sure that we all knew we were on the right page. I don't like the biggest piece of engineering and coding work was the deployment and infrastructure scripts. So provisioning the VPCs, writing the integrations with ECS, that sort of thing. But in terms of actual coding, it wasn't too invasive.
I think that's actually a positive for a lot of people, because I believe there are people who think they need to do a big rewrite if they have, performance problems or problems keeping track of the status of their system. But I think this is a good case study that shows that you don't necessarily need to do a rewrite. You just need to put additional processes and checks in place and maybe change your deployment process to kind of get the results that you want.
It's about the foundations as well. If you have some really strong people at the start who, pave some good roads there in terms of good practices, like just for example, a really good database change management setup, some good packaging of the code, really good packaging of the code. So it was quite easy for us to slip out 5 services from that big monolith. It's about the foundations at the start, because it would be quite easy to build an MVP with some people who write 1,000-line PHP scripts and the product works, and that's a different case study, because you can't fix that essentially.
Right. So it's because the original foundation was strong that you were able to undergo this sort of transformation.
Yeah, truly. Yeah.
Adopting all of these processes, did they resolve all of the key problems your business faced?
When we look back and we see that all of our systems are running on Docker, we see a huge cost benefit. So that problem was certainly solved. We were able to see issues before our customers, so we had better transparency in the system. No longer were we dependent on one big server. 1,000 customers were no longer dependent on one big server. So it meant that we had really good, we do have really good fault tolerance on those containers. If one of them dies, ECS will literally kill it, bring up a new one. It'll also do some auto scaling for us. Say on a Monday morning, you maybe have 8 containers running, but on a Friday, maybe it'll auto scale to 14. So that's been groundbreaking for us. In terms of how we work, we went from shipping monthly to quarterly, from between monthly and quarterly to daily. And something I use as a team health metric right now is our frequency of deployment. And I'd say we're hitting about 25 deployments a week now. Compared to the olden days is great. We always want to get better at it. I would say that those have been really amazing things for us. But also in terms of the team, it's a lot easier for us now to hire a new engineer and bring them in because of this consistency. And also, I guess we're not reliant on these pockets of knowledge anymore. So we, again, around hiring, it's a lot easier for someone to come into the system and know how things work. And I think in terms of hiring as well, when you talk about the kind of setup, it's there's some good stuff happening there.
It sounds like you have a better picture in terms of monitoring the system. You brought your costs down significantly. The deployment process is much easier. The existence of the containers and ECS is kind of serving the purpose of where people used to have to monitor the individual servers and bring them up themselves, but now you've sort of outsourced that to Amazon to take care of. Does that all sound correct?
Yeah, spot on.
And I find it interesting too that you had mentioned that improving all of your processes actually made it easier to bring new people in. And that's because you were saying things are now more clearly defined in terms of what to do rather than all of this information kind of being tribal in a sense.
Yeah. Like a typical example would be like, hey, let's redeploy this bug fix. And say previously, it might be a Capistrano deploy or, you need to get SSH keys to this thing and you need to log in here and you need to build this code on this local machine and try and ship it up. And that just all goes away, particularly with Docker. And that continuous integration pipeline it sets a really good set of standards and things that people should find quite, easy and repeatable.
And so now in terms of deployment, you can use something like CloudFormation and you have the continuous integration process that can deploy your software without somebody having to know specifically about how that part works.
Exactly. So I would say if we wanted to create like a new service responsible for some new functionality in Forrest, say a Spring Boot application, a Java application, they can simply provide a Docker file and get that deployed to dev, staging, or production with, I would say, 10 lines of YAML configuration. So you could go from initial setup of a project to production in a day if you wanted to. There's zero friction there, I would say.
Mm-hmm. It really makes the onboarding a lot easier then.
Yeah.
Do you think your team waited too long to change their processes, or do you think these changes came at just the right time?
I would say if we waited any longer, it could have been detrimental to I guess, the health of the business. I think that the guys did a great job in terms of getting us to a certain point, but we would have risked technical decay, I would say, and kind of really harming the organization if it had have gone any further. I would say it was a lot of work to do this, and it could have been easier if we had have paid more attention to technical debt and making the right decisions earlier on. So maybe saying no to that customer who wants a bespoke piece of functionality. But you have to do what you have to do.
So you would say maybe identifying earlier on just how much the current processes were causing you problems. If you had identified that earlier, you think you might have made the decision to try and make these changes at an earlier time.
Yeah, so the guys earlier were making really good decisions, but maybe they didn't have the experience for higher scalability solutions and systems. So it's about hiring the right people at different stages of where the product is evolving, I would say.
Given what you've gone through with the migration at Forrest, what advice would you give to someone building a new process? What can they do to keep ahead of either technical debt or any of the other issues you faced?
I think it's about how it's actually a people and cultural thing along with tech decisions. So everybody needs to be really aligned in terms of the decisions that they're making rather than letting people go on an individual basis. I think there needs to be good leadership in terms of getting a group of people thinking the same way. I reckon that technical currency is extremely important, and as your system grows, you need to be able to look back and identify areas of pain. And by pain, I mean, speed of deployment, speed of development, and ability to adapt and change your software. So if you notice that a feature that used to maybe take a week is now taking 2 weeks, you probably need to take a really hard look at that area of the system and figure out, could it be simplified, and why is it taking too long?
Basically, identifying exactly where your pain points are, so that you can really focus your efforts and have an idea of what you're really going for.
Yeah, you need to build an environment of trust, and I would also say that you need to be able to be confident and okay with failure in terms of taking risks sometimes and saying no to features and customers, to be able to push back on leadership and make sure that you're really evolving the system the right way and not just becoming a feature factory.
Yeah, it's always going to be a kind of balance on, how much can you pull back but still stay competitive in whatever space you're in.
Yeah. So what we're doing right now, based on those lessons, is we try to do like a 6 to 8 week burst of work, and we would always try and take a week or two wiggle room between that and starting something new to look back at what we just built and make sure we're happy with it, but also look at our technical backlog and see if there's anything there that's really paying us. And just even, for example, this week we noticed an issue with a lot of builds failing on our CI because of how it was set up to push Docker images. So occasionally they would fail, and that was actually a real pain point for us just over the last couple of months, because maybe a deployment which should take 20 minutes was taking 40 because you'd have to retrigger it. So that's just like, that's an example of us looking at what was high value and making sure we just fix it before we start something new.
So making sure that you don't kind of end up in the same situation where you started, where these technical issues sort of build without people noticing them. Instead, kind of in shorter iterations, doing sort of a sanity check and making sure everything is working and we're all going in the right direction.
Yeah, it's about the team. And I mentioned before, it's about, the leadership and a group of people together talking through common issues and, maybe meet every 2-3 weeks, talk about some key metrics in the system. Why is it this too high? Why is this too low? You can, through your peers, you can really see the pain points, and they'll more than likely tell you them.
When you look back at all the different technologies and processes you adopted, did you feel that any of them had too much overhead for someone starting out? What was your experience in general?
So some people just didn't like doing code reviews. Some people just really just felt that they could just push what they needed, and that it was almost a judgment on them in terms of the code review process, which it totally wasn't. I would say some people found Jenkins and continuous integration a bit, what's the point? So we had some, some pain points there. But as we got to Docker, as people seen the benefits of these things, less bugs going into production, less things breaking, people being able to go home nice and early in the evening and not be woke up in the middle of the night with an outage call. Those were all the benefits, and that's us reaping the rewards of thinking like this.
Your team was bringing on a bunch of new things at once. What was your process for adopting all these new things without overwhelming your team?
So it was starting at the foundation. So the continuous integration, the code reviews were incrementally brought in, and we had regular team meetings to discuss pros and cons. And it was really important for people to input on those things rather than to just implement them. They would have failed if we had have done it like that. It took time. I would say we're still not in a perfect world, but it's about group consensus and making sure that everyone's bought into what we're trying to achieve.
So basically getting everyone in the same room and making sure they understand what exactly the goal is and everyone's on the same page.
Yeah, so we try to make a big effort, particularly for people who are working remotely, to get them all in the same room once a quarter. We talk about our challenges, talk about our goals, talk about our values, and make sure we're all on the same page. And sometimes we tweak them, and that's how we feel it's best to do it.
Great. Finally, I want to talk about what's next for Forrest. What are the remaining pain points you have now, and what do you plan on tackling next?
So right now we're on 4,000 salons on our platform. We're really happy with the state of the infrastructure to get us to maybe 8,000 to 10,000 salons, but we need to be really conscious of the company's growth and our goals. So we need to make sure that we can scale at a much bigger level. And we also need to make sure that our customers aren't affected by our growth. We're looking at serverless for any kind of newer pieces of the product to see if they can help us reduce costs even more and help us stay agile in terms of our infrastructure and how we roll out. A couple of years ago when we launched into the USA, we noticed it doubled our overhead in terms of infrastructure, operations and deployment. And as we grow in the US, we need to be really conscious of not making any mistakes from the past.
So you're mostly looking forward to additional scaling challenges and possibly addressing those with serverless or some other type of technology.
Yeah. So one area in particular will be our SMS sending. So that's kind of a plan for the next 6 to 8 months would be to make sure that we can continue to scale at the growth rate of SMS and email sending, which is huge in the platform.
You said so far you've been experiencing 30% growth year over year. Mm-hmm. And you said when you moved to the US, you actually doubled your customer base? I'd
say we doubled our overhead in terms of infrastructure, managing deployments. We're still very early stage in the US, and that's our big focus for the moment. But as we grow there, we need to be, I guess, more operationally aware of how it's going over there. It's a much bigger market.
To kind of cap it off, how can people follow you on the internet?
Sure. So you can grab me on Twitter at John Will Doran, JOHNWIL Doran. And if you ever want to reach out to me and talk to me about any of this type of stuff, I'd love to meet up with you. So feel free to reach out.
All right, John, thank you so much for coming on the show.
Thanks so much for having me.
This is Jeremy Jung for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.